Okay, so in our last video we were going over prime factorization and its different uses, and it got kind of long, so I didn't really get to do my division tricks. So if you're looking just for absolute value, bear with me for a couple seconds while we finish the last segment of the prime factorization. So prime factorization is useful because it lets you do many different things very quickly. Well, there's certain division tricks that you can use as well. So let's say you have a number, okay, 1000 over 3000, okay? When you have multiple zeros in a fraction, an easy trick you can do is you can take off all the zeros, right? And then you can see that 1000 over 3000 is the same as 1 over 3, right? So it works with any number, so it could be a variation of zeros, right? So it could be 2 zeros here, right? And 1 0 here. You can take out 1 from here, 1 from here. You have 120 over 36. And this can be reduced further, but that's just to illustrate the point of the zeros. Okay? Another quick division trick is that, let's pretend we have this. Okay, so we have 6/9, okay? Most of you can probably see that you can divide 6/9, okay? Divide the top by 3, divide the top by 3. Pretty easy to see that, right? Well, it doesn't just work with this. You can expand this to any number of things. So if you had, let's say, okay, 18 over 27, right? Now, again, we know that both of these numbers, we know 18 and 27 are both divisible by 3 almost immediately. But if it was a number you didn't recognize, if you take these numbers, okay, 1 and 8, 2 and 7, and you add them, you get 9 over 9. If you get something that's divisible by 3, then you know that it's divisible by 3. And that works for anything. So if it was the number, okay, 8 plus 1, okay, plus 3, okay, plus 3, oh, plus 6 in this case, alright, over, let's say, 27, okay. So we have 8,136 over 27, right? So here, I'm going in reverse in this case, but 8 plus 1 is 9, plus 3 plus 6, 9 plus 9 is 18, that's divisible by 3, so you know this entire number is divisible by 3. So you divide it by 3, and you go through it, and it's going to work. Okay. This is also true for 9. 3 and 9, it works for. Okay. Another quick division trick is how to know if it's divisible by 5. Okay. If it ends in 5 or 0, it's divisible by 5. It's as simple as that. So if you have the number 1250, it's divisible by 5. If you have the number 100, it's divisible by 5. 5, 5, 5, 5, 5, 0, 0, 5, 5, divisible by 5. If it ends in 5 or 0, it's divisible by 5. So quick recap. If you have multiple zeros, okay, you can take away as many zeros as you do on top from the bottom. Okay. It works even if you have a different amount of zeros on top. Okay. 1 and 1. And you're left with 120 over 36. Okay. To find out if something is divisible by 3 or 9, simply add the numbers. And if you get something that's divisible by 3 or 9, then it works. And to find out if it's divisible by 5, it has to just have end in 0 or 5. Okay. Now, we all know if it's divisible by 2, okay, because it ends in an even number. Okay, so anything that ends in an even number is divisible by 2. Okay. Now, 99, 88, 77, 66, 55, etc., all the way down to 11 are all divisible by 11, and those are easy to see. So those are some quick, easy tips about dividing easily. To be able to reduce a fraction without a calculator, that's the whole point of it. Okay? So then that brings us to absolute value. The definition of absolute value, right? So the absolute value of A, okay. Now we're going to set up a piecewise function to define absolute value. is a or negative a. Okay, it's a when a is greater than or equal to 0, and it's negative a when a is less than 0. Okay? So, granted, we haven't learned what piecewise functions are yet, but basically, if you read this here, it says it's going to be the number that's inside the vertical bars if that number is greater than or equal to 0. Okay? So if you have vertical bars, okay, which is absolute value, let's say 3 is definitely greater than or equal to 0, the number is simply going to be what's inside 3. Okay? Now, if that number that's inside, okay, is less than 0, it says do negative a, right? Or negative that number. So if you have vertical bars negative 3, okay, the absolute value, if it's less than 0, less than 0, that's a true statement. You do negative what's inside, okay? And then you get 3. In other words, anything placed inside an absolute value is always going to spit out a positive number. Anything you put in. You can put in 3, you can put in negative 3, you can put in negative 2, negative 1, 0, anything, it's always going to give you a positive number. Okay? This is going to give you 3, this is going to give you 3, this is going to give you 2, it's going to give you 1, it's going to give you 0. Another way of thinking of absolute value is as distance. The reason why you're always going to get a positive number is because let's look at it graphically. Okay? Some Silent Hill type graph. Okay, we're just going to draw it. So let's say you have negative 3 and 5. Okay? So what's the distance between negative 3 and 5? Well, we could plot all the little points. We get negative 2, negative 1, 0, 1, 2, 3, 4, and then 5, right? And then we count 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the distance is 8, right? So the way you can show that, okay, algebraically is the distance is implying subtraction, always, minus 5 gives you negative 8. Absolute value of negative 8 is 8. The distance between negative 3 and 5, okay, is positive 8. Okay. Why is that? Well, you simply can't have negative distance. Okay. So that's why absolute value is useful. The piecewise function that defines absolute value is going to make much more sense later on in the videos. Now here's a difficult, or a little bit more difficult version of the same problem. If they gave you, let's say, the absolute value of negative pi, what would you get? Well, negative pi is pi distance from 0, right? So let's show that again. We have 0 here. Say we have pi here, and we have negative pi here. Okay? If you were to count all the intervals between 0 and positive pi, and 0 and negative pi, okay, you would get the same distance. Okay? Negative pi is the same distance from 0 as positive pi is from 0. That's why we get positive pi. Right? Now, let's take that concept a little bit further. If you had 6 minus 2 pi, okay, what would be the answer? What would be the absolute value of 6 minus 2 pi? Well, if we go back up to here, okay, where we defined absolute value, okay, so let's do absolute value, let's redefine it. Okay. When x is greater than or equal to 0, it's going to be equal to x. Negative x, when x is less than 0, so definition here, we evaluate what's on the inside real quick. Okay, 6 minus 2 times pi, we know pi is greater than 3, so anything greater than 3 times 2 is going to give you something greater than 6. So whatever number this is going to give you a negative overall number. Okay? So it would be like, so let's just do at least the values I know of pi, 3.14, right? Times 2, just to evaluate real quick. You get 8, 2, 6, right? So 6 minus, we're rewriting it here. 6 minus 6.28 is going to give you negative 0.28, which is a negative number. So we're going to use it here, right? So we're going to take this, okay, times it by a negative, and we're going to get positive 28, right? Now, this is an approximation, right? So to keep the same and better distance, we do negative 6 minus 2 pi, okay? Distribute the 6 here, distribute here. Okay? And that's going to be the answer to that. Okay? So, if you notice, this video got a little bit more involved, okay? There's going to be a marked difference in the difficulty of the next videos, okay? So, if you were able to follow everything in this video, then you're going to be able to follow the rest of the video series. It's going to be about this level of difficulty. Okay? I'll see you next time.